Hi, this is Jim Harris, and I'm at Photonics West today, and I'm talking with Arun Chabra, who is a business development manager, from Texas Instruments, and in the famous DLP area. And Texas Instruments has some new development kits to talk about, right?
We do, as a matter of fact, Jim. So what we're showcasing and what we announced here at Photonics West this week is our latest in the series of DLP development platforms. It's called the DLP Light Commander. And really at its core, it's designed around market feedback that we've received over the last couple of years to create a modular, flexible development platform that's easy to use and also affordably priced. So the Light Commander is designed to have a modular optics assembly, modular illumination block, and an interchangeable lens. It comes with a user interface for your PC that allows users a good degree of access to controlling the mirrors on the chip, on the DLP chip. The modularity really gives users flexibility to interchange custom optics as they need it, but out of the box it comes with everything necessary to allow them to get a feel for how to use the DLP chip.
Okay, so I think you had, Arun, you had a high-end kit before that's very versatile, but not really set up. You have to kind of set it up yourself. And you've had the low-end kit for, what was that?
So we've had the high-end Discovery Series kits, which still exist. They're still in demand. Okay. Those start at about $5,000 and go up because they're very full-featured and full performance, handle UV, IR light as well. At the low end, we have the Pico kit, which we've announced an upgrade to at this show with higher pattern rates of up to 1440 patterns per second, and also the capability to connect the Pico kit directly to a PC. You'll recall that last year the first version connected only to the Beagle board. Yeah, right. So again, in response to the market, we've upped the version of that. Okay. So those are the two introductions this week. Now those fit at both ends of the portfolio of kits, and the Light Commander sort of occupies a sweet spot in between. It's at $24.99 and really targeted to tailor for development with the broad masses of the development. The Light Commander contains DLP technology, which is obviously from TI. But its overall design and manufacturing is from our partner Logic, a product design company out of Minneapolis. The optical block inside the Light Commander is actually developed by a DLP partner, Visitech, out of Norway. And then where we just came from, you saw something on the screen flashing over there, and maybe we can walk back and I can show you that. This is just a demo application that one of our other DLP design houses, Violux out of Germany, has created expressly for the purposes of showcasing how you can do a quick out-of-the-box experience with the DLP Light Commander. So over here, let me just take a quick second. This is a pattern of very basic fringes being flashed on a target, the target being now my hand. You can see it's moving in real time. Right. And you can see the fringes on my hand. You can see the wrinkles. So in real time, you're able to tell depth, XYZ dimension. Okay. Again, this is just a demonstration. If a user were to fine-tune the algorithm, put in higher resolution camera sensors, and possibly higher capability and fine-tuned optics, they could have down to the micron level of depth accuracy.
Gotcha. So in the box here we have the light source and the cameras over there.
Yes, so the box has light source, optics, electronics, lens, and outside you have the camera.
Excellent package for development. Now, I know that you've expanded this some from from the consumer electronics, from the projectors. So how many different I probably have hundreds of applications for this, especially in science, but maybe a few of them.
Sure. Yeah, we do have a lot of applications that customers are developing outside of video projection. Two very, interesting ones are, if you think about the way PCBs are manufactured, they're traditionally been done with a mask layer. So an expensive process, and if there's ever an error, there's a significant expense involved with redoing a mask. Industry is moving away from the mask process to something called direct imaging PCB lithography, where you just have the PCB with photosensitive resist, and you use the DLP chip essentially to do direct UV exposure or visible light exposure on this photoresist to basically draw out your circuit patterns. It's very quick, and if there's an error, all you do is load a new software file with the updated circuit pattern and expose it out again.
So the DLP can handle that spectrum of light, no problem.
Yes, the DLP chips are capable of handling UV, visible, and near-infrared wavelengths.
Great. One other application.
Another application would be 3D optical measurement, which is really what this demo is showcasing. Principle being, it's a broad space, Jim. It's got a lot of different applications under this umbrella of 3D optical measurement. So the principle is flashing light onto a target, reading the phase offset of those fringes off the target to tell some information about the Z dimension of, or the depth of that object. So you get a high accuracy of measurement using light. It's not contact based.
So quality control certainly would be.
Quality control, or if you think about the turbines in turbine blades inside a turbine jet engine.
Yeah.
Well, if they constantly inspect the blades periodically to see which one's having more wear and tear than others, they can quickly replace that and extend the life of the overall turbine. Yeah,
okay.
Exactly. And they do it all with light rather than touching it.
So, good. That sounds great. Arun, thank you very much.
Jim, thank you for your time.
You
It's
bet.
fringes on my hand.